Hello everybody, this is Tommaso. Today we talk about rehabilitation and assistive robots. Goals of rehabilitation and assistive robots. Augment rehabilitation, restore biological accurate gait, and restore sensory motor performance. How are healthcare robots defined and what are they used for? These are the questions that we are going to ask ourselves today. Let's talk about rehabilitation. Rehabilitation robotics is a field of research dedicated to understanding and augmenting rehabilitation through the application of robotic devices. Rehabilitation robotics includes development of robotic devices tailored for assisting different sensory motor function: arm, hand, leg, ankle. Development of different schemes of assisting therapeutic training and assessment of sensory motor performance, the ability to move, of a patient. Here, robots are used mainly as therapy aids instead of as an assistive device. Rehabilitation using robotics is generally well tolerated by patients and has been found to be an effective adjunct to therapy in individuals with motor impairments, especially due to strokes. Methods. Rehabilitation robots are designed with applications of techniques that determine the adaptability level of the patient. Techniques include but are not limited to active assisted exercise, moving predetermined path without resistance, active constrained exercise, move with opposing forces if on the wrong path, active resistive exercise, move with opposing forces in general, adaptive exercise, design specific exercise routines to meet the needs of the patient, and passive exercise, move the patient without him exerting any force. So over the years, the number of rehabilitation robotics has grown, but they're very limited due to clinical trials. Many clinics have trials but do not accept the robots because they wish they were remotely controlled. Having robots involved in the rehabilitation of a patient has a few positive aspects. One of these ones is the fact that you can repeat the process or exercise as many times as you want. So as we were talking about it, we have repeatability of the process. You can repeat an exercise as many times as you wish. Another positive aspect is the fact that one can get exact measurement of the improvement or decline of the patient, and one can do that through sensors that are directly fitted on the device. And while the device is taking measurement, one needs to be careful because the device can be disrupted once it is done because of different movement that the patient does to get out. The rehabilitation robot can apply constant therapy for a long period without getting tired or getting injured, for example. In the process of recovery, the rehabilitation robot is unable to understand the patient's need, though, like a well-experienced therapist would. So there is this lack of understanding and empathy that is a major drawback. And although the physical effort at the same time does not appear as an issue, as no physical effort is required by people, the robot comes very handy to that respect. Lately, rehabilitation robotics have been used to in training medicine, surgery, remote surgery, and other things, but there have been too many complaints about the robot not being controlled by remote. Many people would think that using an industrial robot as a rehabilitation robot would be the same thing, but this is not the case. Rehabilitation robots need to be adjustable and programmable because the robot can be used for multiple reasons. Meanwhile, an industrial robot is always the same, it is constructed in a very specific way, and there is no need to change the robot unless the product it is working with is different. So in order for an industrial robot to work, it would have to be more adjustable to new tasks, and that is just not the case. So remote control is still an issue for rehabilitation robotics. Now, these are just a few examples here that you can see, a few different examples as well. Both cases of rehabilitation, but working in a pretty different way. And now let's talk about assistive robotics. So this field is slightly different to rehabilitation robotics, as this is about devices that integrate lacking sensory motor functions for patients And the main features are recovering impaired or lost ability to move, and they're usually employed outside of the healthcare system, so they're not within it, and they are for people to use them in their day-to-day life. From a technical perspective, achieving the vision of a symbiotic relationship between human and machine required overcoming several major and often conflicting challenges. So what we aim to do is, for example, design exoskeletons and prosthetic limbs and create a seamless interface between human and robots, and achieve a conscious and subconscious control over tunability. But in general, we have numerous sub-goals, let's say. So again, there should be some kind of a symbiotic relationship between human and machine, but this produces a series of issues and challenges. One, for example, is power consumption, which should be minimized on both sides of the interface to reduce metabolic burden on the user and extend runtime for the robot. The actuator and force transmission mechanism should be lightweight, energy efficient, and compatible with the natural biomechanics of the human. And there has been some demonstration about soft exoskeleton suits that can reduce metabolic cost of walking, for example, and the influence on balance and natural movement. But given the distinct nature of individualized gaits among users, personalized assistance offered by device is a very important factor. Let's talk about the main challenges of this field. So first we have tunability. Of course, we need the robots to be extremely adaptable and extremely fine-tuned on the person that is using them the most and wearing them. Then we have power consumption. Of course, we aim for the electrical systems to be as easy on the power as possible, which provides several advantages. And also we can talk about power consumption in terms of the human, so they shouldn't be too heavy, they shouldn't introduce too much effort on the human that is using them. And then we have the force transfer between robot and human, which is a very delicate and difficult side of the issue to handle, as force transfer should be seamless and should allow the user to feel comfortable with the robot. Then we have neuromuscular control and coordination. So in order to achieve complete substitution, for example, of a limb, the user should be able to use the prosthetics as if they were their actual limbs, and as such it would require sensory feedback, so touch and pain, which currently is not achievable. And finally, safe, intuitive, and reliable behavior, which is self-explanatory, but we need safety, a layer of safety and reliability, as these robots are going to be introduced in a day-to-day life of people and will need to have a certain degree of robustness, but at the same time they should be intuitive, as it is with the current state of limbs for humans. And in general, they should allow people to use them seamlessly without any kind of mental burden on them.